In Chapter 7, we're going to begin factoring. And the whole point of factoring is basically to undo the multiplication that we learned back in Chapter 6. So our first type of factoring is going to be factoring by GCF. In Section 7.1, we learned how to identify the GCF using a systematic process. So we're going to now take a GCF, identify it, and factor it out. So we're going to start off with 4 warm-up problems. 1 and 2, we have products here where we have to distribute, and 3 and 4, you're asked to find the GCF. So let's check your work here. In 1, we distribute the 2 in, 2w plus 2. In number 2, we're distributing 3x, which gives us 3x cubed minus 12x. 3 and 4, we're finding the GCF. And generally speaking, if I'm just looking to pick out a GCF and I'm trying to avoid potentially having to do all of the side work, I want to look at the smaller of the 2 numbers and see if it divides evenly into the larger one. Well, 4 doesn't divide evenly into 6, so now I'm going to start thinking about other factors of 4. Well, the only other factors of 4 are 2. So 2 goes into 4, 2 goes into 6. Looking at the variables, as long as they share a common variable, we take the lower of the powers. So our GCF here is 2h. Looking at number 4, 13p and 26p to the 6th. Again, looking at the smaller of the 2 numbers, 13 does divide evenly into 26. And we do have p's in common. Smaller power is p to the 1st, so our GCF is 13p. So our goal for today is to be able to factor polynomials by using the greatest common factor. So we're going to undo this multiplication that we just did in 1 and 2 of the warm-up. Okay, so we're undoing distribution. And we can check our work by distributing. So once we identify what our GCF is, we're going to factor it out or pull it out. And the process of pulling it out is dividing it out. So once we identify the GCF, we're going to divide it out of each term and drag it along. So we're going to divide and drag. So take a look at these 2 examples. If I look at 2x squared minus 4, both of these terms have a 2 in common. No x's, just 2. So if I divide a 2 into 2x squared, I'm going to be left with x squared. If I divide a 2 into 4, I'm going to be left with 2. Drag along that GCF of 2, so 2 times the quantity x squared minus 2. The work shown here is a little bit different than what we do, so don't worry too much about that. And then if we look at the next one, we want to keep in mind, and you'll see it in several problems, we don't like negatives in the front. So we're always going to pull out a GCF of -1 if we do have a -1 in the front, and then it continues on factoring out a 2 and an x that they have in common. Okay, so that's something to store in the back of our mind for later. But the most important thing with factoring is just practicing. Okay, so we're undoing our multiplication process. So jumping into our first example, number 1, we have 8x cubed minus 4x squared minus 16x. Okay, so the polynomial is in standard form, highest power down to lowest power. And now let's see if we can identify what all 3 terms, if anything, they have in common. So looking at the smallest of the numbers, 4, does 4 divide evenly into the other numbers, 8 and 16? Well, yes, it does. So numerically, our GCF is going to include a 4. Now all 3 terms have an x. The smallest of our x powers is 1. So our GCF is 4x to the 1st. So I'm going to identify that, and now I'm going to show that in order to quote-unquote factor it out, I'm going to divide that GCF of 4x into every term, and then I drag it along on the outside. So we're left with 4x on the outside times the quantity, okay, 8 divided by 4 is 2. X cubed over x is x squared. Then I have a minus sign. 4 divided by 4 is 1. X squared divided by x is x to the first. 16 divided by 4 is 4. We had that minus sign, so we have minus 4, and the x's cancel. So here's our answer. So we've got 4x times the quantity, 2x squared minus x minus 4. So we undid the distribution of that 4x. So we can check our work by distributing the 4x back in. So we would do 4x times 2x squared. 4 times 2 is 8. X times x squared is x cubed. 4x times negative x, that's going to give us a negative. 4 times 1 is 4, and x times x is x squared. And 4x times negative 4, positive times negative is negative. We've got 16x. Okay, so distribute back through, make sure we get what we started with. Number 2, we've got 3x cubed plus 2x squared minus 10. Our polynomial is in standard form, highest power down to lowest power. Do they have anything in common? Well, if I look at my smallest number, it is 2. 2 does not divide evenly into 3 or into 10. And 2 is prime. So 3, 2, and 10 have nothing in common other than that 1. Also, this negative 10 in the back doesn't have an x. So they don't all have a variable. So our GCF here is 1. These terms are relatively prime. And when their GCF is 1, or you look at it as though there's nothing in common, that means that this is not factorable. Looking at number 3, we've got 5b plus 9b cubed. Now, I personally don't love the way that this is laid out due to the fact that this is not in standard form, highest power down to lowest power. So let's rearrange it. It's a positive 9b cubed plus a 5b. So do 9 and 5 have any common factors? Well, 5 doesn't divide evenly into 9, and 5 itself is prime. So nothing numerically. But they both have b's. The smallest power here would be a b to the first. So our GCF is b, just plain old b. So we're going to divide and drag that GCF of a b. When I do 9b cubed divided by b to the first, we're going to be left with 9, because 9 divided by 1 is just 9, b squared, because b cubed divided by b to the first is b to the second, plus 5, and the b's would just cancel here. So 9b squared plus 5 will remain inside. So I now took this polynomial number 3, I factored it, and wrote it as a product. We could check our work by distributing. So if I take my b and distribute through, b times 9b squared is 9b cubed. b times 5 is positive 5b, which is technically what we started with. Looking at number 4, 9d squared minus 81. Look at the smallest number, 9. Does it divide evenly into the other term? Well, 81 is divisible by 9. Okay, so that's good. So we've got a 9 in common. but they don't both have any variables. Okay, the first term has d squared, the other one doesn't have any, so they don't share any variables. So our GCF here is simply 9. So we're going to divide and drag the 9. Once we divide it, technically in our first term, the 9's would cancel, we're left with d squared. And I've got a minus, 81 divided by 9 is 9. Always double check that on the inside there's nothing else that all the terms share. And there's nothing in common between d squared and that negative 9. We could check again through distribution, but I'm not going to check every single problem. Now, should you check your work when you're taking a quiz or a test? Absolutely. Let's look at number 5. We've got negative 18y cubed minus 7y squared. This is in standard form, but we have a negative in the front. We don't like negatives in the front. So part of our GCF is going to include a negative. Now let's look at the numbers. If I just think of them as the absolute value, just the positives, 18 and 7. 7 is the smallest number. Does it divide evenly into 18? No. 7 can't be broken down any farther. So numerically, they don't have anything in common. Variables, they both have y's. Smallest exponent is y squared. So because we have that negative in the front, we're going to pull out, and I'm going to write it as a negative 1 y squared as the GCF. So when we divide both terms by negative 1y squared, and we do our division, negative 18 divided by negative 1 is going to be positive 18, and y cubed divided by y to the second is y to the first. Now I have a negative 7 divided by negative 1 gives us a positive 7. And y squared divided by y squared, well, they cancel. Now that negative 1, the 1 here is redundant, but I like it there for now, just so you make sure you don't forget that we have to pull that negative sign out. Okay, this wouldn't be a bad idea to check this one. Negative 1y squared times 18y plus 7. If I distribute, negative 1 times 18 is negative 18. Y squared times y is y to the third. Negative 1 times 7 is negative 7, and we've got the y squared. It's exactly what we started off with. Number 6, 8x to the 4th plus 4x cubed minus 2x squared. Look at the smallest number, 2. Does 2 divide evenly into the others? Yes, it does. So our GCF is going to include a 2. And all three terms have x's, smallest power being x to the second. So our GCF is 2x to the second. So we divide and drag a 2x squared. Eight divided by 2 is 4. And x to the 4th divided by x squared is x squared. So 4x squared. Plus 4 divided by 2 is 2. X cubed divided by x squared is x. And then we have a minus. 2 divided by 2 is 1, and x squared divided by x squared is 1, so we just have minus 1. Make sure if everything cancels when we are dividing, you have a 1 remaining. Quick visual inspection, nothing else in common here. Next we have a little word problem. It says to write expressions for the length and width of a rectangle with area expressed by a polynomial, you need to write the polynomial as a product. You can write a polynomial as a product by factoring it. Okay, so this is telling us that the area of a court for the game squash is 9x squared plus 6x squared meters. Factor this polynomial to find possible expressions for the dimensions of the squash court. So we want to take the expression that represents the area and we want to break it apart into a product, so then we technically can find dimensions, a length and a width, to represent this situation. So if we look at number 7, it says the area of the solar panel on another calculator is 2x squared plus 4x centimeters squared. Factor this polynomial to find possible expressions for the dimensions of the solar panel. Okay, so the solar panel is a rectangle, and rectangles are area equals length times width. And this area is given by this polynomial. So area equals 2x squared plus 4x. So we want to break it apart as a product. To find expressions for dimensions, length and width. Okay, and if we want to break it into a product, that means we're factoring. So what do these two terms have in common? Well, 2 is our smaller number. 2 does divide evenly into 4. So we have a GCF of 2, and they both have x's. Smaller power being x to the first. So our GCF is 2x. So if I divide and drag a 2x, we can now say that our area can be represented as drag the 2x along the outside. 2x squared divided by 2x is 1x, plus 4x divided by 2x is 2. Okay, so now we have our area represented as a product that could therefore represent length and width.